everyone. Today we will discuss transistor as a switch. Transistor is one of the electronic circuit which is generally used as an amplifier. But this is the second application of the transistor which is also used as a switch. We know the three operating condition of the transistor, which is nothing but the active, saturation and cutoff. When you use transistor as an amplifier, it should be operated in an active region. But when you use the transistor as a switch, it is operated only in the cutoff or saturation region only. So, what is the theory behind the transistor as a switch that we will discuss first? See here, in the transistor operate in the cutoff or saturation region in case of the switching circuit, or when you can say when the transistor used as a switch, it is operated in cutoff or saturation region. In cutoff condition, it is nothing but the off condition, and in saturation condition, it is referred as a on condition. You know already in cutoff condition, both the emitter and collector junction are reverse bias. As the in case of the reverse bias, only reverse current flows, which is nothing but the negligible. And in saturation condition, both emitter and collector junctions are forward bias. When both emitter and collector junction are forward bias, base and collector current flows at the base and collector terminal, and the voltage at the base and the collector terminal, which is nothing but called as the base to emitter saturation voltage and collector to emitter saturation voltage, whose values are base to emitter saturation voltage is of 0.8 volt and collector to emitter voltage is of 0.2 volt if the transistor is made up of silicon, and it is 0.3 volt and 0.1 volt for germanium transistor. In the saturation condition, the value of base current is very large as compared to the collector current. For beta times, beta is the current gain, whose formula is the collector current upon base current. So we have to see the two condition circuit diagram and theory of the transistor as a switch. First condition is nothing but the cutoff condition. This is the first condition of the transistor, that is nothing but the cutoff condition. This is the circuit diagram. You can see here in the cutoff condition, when the input voltage is zero, then no current is flowing at the base terminal. Base current is zero, and also collector current is zero. These are the theoretical values, but practically negligible current is flowing at the base and collector terminal. So no current is flowing. Hence, transistor is acts as an open switch, and as the no current, due to the no current, there is no voltage drop at the collector terminal. So there is no voltage drop. Hence, you got the output voltage, that is nothing but the VCC. So in one word, you can say that when transistor operated cut off, output voltage is VCC. VCC nothing but the 5 volt, which is also called as the logic 1. So input voltage is 0 and output voltage is 1 in case of the transistor, when transistor operated in a cut off condition. So you can see that in figure, when input voltage is applied is 0 volt, reverse current is flowing at the base terminal and the collector terminal. So when you apply the Kirchhoff voltage law at the collector terminal, VCC minus ICRC minus VOut, as IC is equal to 0, you got the output VCC. This is the first condition of the transistor as a switch cutoff condition. Now the second condition is nothing but the saturation condition. In the saturation condition, when you apply the input voltage V, base current is flowing to the base terminal and to the collector terminal. Collector current is flowing. In saturation condition, emitter and collector junction both are forward bias. So you can in this when as the current is flowing at the base terminal and the collector terminal, this transistor which acts as a closed switch. As there is the closed switch, there is the voltage drop occurs at ICRC at the collector terminal. So you got the output voltage that is nothing but the very small value. It is also called as the collector to emitter saturation voltage, whose value is zero point 0.2 volt for silicon transistor and zero point 0.1 volt for germanium transistor, which is very very small. So you can say that when you applied the voltage plus 5 volt at the input, you got the output voltage theoretically zero. It is nothing but the logic zero at the output. So this is exactly opposite to the cutoff condition. So in figure B, when input B voltage is applied to the transistor, the emitter junction is forward bias and collector junction is also forward bias. Collect so at both the terminal current is flowing. So there is the voltage drop at the collector terminal. Hence you got the output voltage is nothing but the Vout is nothing but the collector to emitter saturation voltage, whose value is zero point 0.2 volt for silicon and zero point 0.1 volt for germanium. So this is the transistor which is used as a switch. 0 or 1, it gives the output 0 or 1. In cutoff condition, it gives the output 1, and in saturation condition, it gives the output 0. So you can write down the theory and draw the circuit diagram for the transistor as a switch. Thank you very much.